In the next video from the chapter solid state, we will study the relationship between molar mass, density of substance and edge length of unit cell. Molar mass given by capital M, density given by rho and edge length given by A. Let's see the points. First point is, let the edge length be small a, the volume becomes A cube. We know that volume is equal to L into B into H. So here the edge length is A. We are considering a cubic system, a cube. All the three lengths, that is length, breadth and height, they are same given as A. So volume becomes A cube. Second point is, let the mass of one particle present in the unit cell be m. एक particle's mass is m. If there are n number of particles in the unit cell, then the mass of unit cell becomes m into n. Now, density is equal to mass upon volume. So, rho is equal to m into n upon A cube. We have considered that mass of unit cell is m into n, where m kya hai? Mass of one particle and n is number of particles. So we get m into n upon A cube. Next formula is molar mass capital M is equal to mass of one particle into Avogadro number. So molar mass M is equal to small m into Avogadro number. So we get small m is equal to molar mass upon Avogadro number. So m is equal to m upon Na, where Na is the Avogadro's number. Now let's see how we have got this formula. This you will not find it in the book, but we will try how we have got this formula. Now we know that molar mass of a substance is equal to Avogadro number of particles. We say 1 mole मध्ये Avogadro number of particles आहेत and 1 mole म्हणजे किती? It is molar mass of the substance in grams. म्हणजे I can say की कुठल्याही सबस्टन्सचा मोलर मास आपण घेतला तर त्याच्यामध्ये I will get 6.022 into 10 raised to 23 particles. So if I consider sodium, see I have taken example of sodium here. If I take sodium 23 grams, because 23 is the atomic mass of sodium. 23 gram of sodium contains 6.022 into 10 raised to 23 particles. म्हणजे 6.022 into 10 raised to 23 particles weight हा 23 grams आहे. तर what is the weight of one particle of sodium? So let it be small m. Let that weight be small m. Cross multiply and find the value of small m. You get small m as 23 upon 6.022 into 10 raised to 23. That is, mass of one particle small m is equal to molar mass capital M upon Avogadro's number. Hence, I get the formula which is written with black ink here, that small m is equal to capital M, that is molar mass, upon Avogadro's number. Now, substituting this equation in the equation of density, we will get the density is m into n upon A cube. So here we will substitute density is equal to m into n upon Na into A cube. Density च्या formula मध्ये इथे density is given rho m into n. M ची value आपण m upon Na ही substitute केली. So we get the final formula rho is equal to m into n upon Na into A cube. So this is the relationship that you get between density, molar mass of the substance and edge length. So on this you may get the problems. Now the next point is to study the packing efficiency of metal crystal in simple cubic lattice. In simple cubic crystal, we have only one type of crystal to study, simple cubic. आता simple cubic मध्ये 3 types आहेत. Cubic system मध्ये one is simple cubic, in which you will find particles present only at the corners of the cube. We have second type as body centered cubic. Body centered मध्ये along with the corners, one will be present at the center and other is face centered cubic. All the 3 systems we have already discussed. So we have to see today the packing efficiency. How efficiently the spheres are packed in simple cubic crystal. So see the steps. First thing is radius of the sphere. We will first calculate radius of the sphere. Sphere here is nothing but the particle. Now consider the sphere having its radius r and the edge length of the edge is a. So we get a is equal to 2r. Now you will understand through the diagram. So r we get as a by 2. Now in this slide you will come to know, when you see the diagram here, we are seeing the diagram here in 2 dimension. This is a cube in the figure. It's a cube drawn. आता इथे it's a square. Cube हा 3D मध्ये दिसेल. This is shown in 2D. This is a diagram taken directly from the textbook. Here you will find on each corner a particle is present. So on one edge radius of particle is coming, of one particle is coming. म्हणजे एक edge वरती there are 2 radii coming. One radius of one particle and radius of another particle is coming. From the diagram it's very clear. So I can say that A is equal to 2r. Right? So in the second step now, I will calculate the volume of sphere. The volume of sphere will be equal to 4 by 3 pi r cube. This is the formula for volume of sphere. Sphere is here nothing but the particle. 4 by 3 pi r cube. The volume of one particle will be 4 by 3 pi. R च्या place वरती I'll substitute a by 2 whole cube. I get pi a cube upon 6. Now in step 3 we will calculate total volume of the particles. Now in the simple cubic system, simple cubic unit cell, at the corners we have particles. At each corner there is only 1/8 particle coming. These all points we have discussed earlier. At each corner 1/8 particle is coming and there are 8 corners. So 1/8 into 8 म्हणजे total फक्त एकच particle येतो simple cubic unit cell मध्ये. So in simple cubic unit cell only one particle is present. So volume occupied by the particle in unit cell will be pi a cube upon 6. म्हणजे जो आपल्याला वरती आला व्हॉल्यूम तेवढाच व्हॉल्यूम युनिट सेलमध्ये वन पार्टिकल ऑक्युपाय करणार. हेच सपोज 2 पार्टिकल्स आले असते तर आय वुड हॅव मल्टिप्लाइड दिस व्हॅल्यू बाय 2. दिस इज व्हॉल्यूम ऑक्युपाइड बाय वन पार्टिकल and in unit cell simple type there is only one particle coming. So we can calculate the packing efficiency by using the formula volume occupied by particle in unit cell upon total volume of unit cell into 100. We are calculating the percentage. So we get volume occupied by particle is pi a cube upon 6 upon total volume of unit cell is a cube into 100, and finally you get the answer as 52.36%. So you can conclude here that in simple cubic lattice 52.36% of the total space is occupied by the particle and 47.64% is empty space. That is, it is the void space that is present. Void means extra space, empty space that is present. A vacant space is called as void. So packing efficiency of simple cubic lattice is 52.36. See, these values must be learned by you.